Thanks for the presentation, Jim, and thanks for inviting me to having my speech here. Before I start, I really like the last take-home message here from the last speaker when he stated that there is no shortcuts to field-based methods when it comes to detailed data. That's exactly what we are believing in Sweden too. I will try to give an overview over biodiversity and landscape monitoring in Sweden. And I will do that by briefly present three nationwide programs. The first two, the NILS program and the Swedish NFI, is what you can call the multi-purpose programs. And the last one, the Life Moth program, is a slightly more specialized program. And all these three programs are currently organized and running from our department at SLU in Umeå. And we have also realized that the collaboration between the programs and information exchange are very valuable, not only for us to do things more efficiently, but we also think that we can give added value to our stakeholders. The demands for landscape data, our view is that it's very important for us to see who are the stakeholders, who wants our data, because collecting data per se is not a good idea. You have to have a receiver for the data. And I think the most important receivers that are creating these demands currently for us when it comes to biodiversity data is the CBD process. For example, the indicators that is asked for internationally. We also have a nationwide process with environmental objectives in Sweden that are in many ways mirroring the CBD objectives. Of course, we have the climate change aspects, the Kyoto Protocol, the carbon stock estimations. And lastly, in Europe, we have the European Habitats Directive. And that is something that I will focus on today, a little bit at least. The surveillance of the conservation status and the report on the implementation. And the Habitats Directive is specifically targeting habitats of certain interest and species of high conservation value. And I believe that the Habitats Directive is changing the way we are working with conservation biology in Europe a lot, especially in Sweden, I think. It is speeding up the introduction of evidence-based decision-making, and it's speeding up the use of adaptive management. And the reporting requirements are really demanding. We have to report on a lot of things. We have to measure the range and areal coverage of a lot of habitats and species. We have to understand the important structure and functions of habitats, and we have to make prediction of future prospects. And this is going to be reported every 6 years. We also have to identify main pressure and future threats for all of these kind of units that are measured. And in Sweden, that means that we have to report on 88 habitats, most of them terrestrial, some of them marine. We have to report on more than 120 species. And this assessment should be done separately within 3 different regions in Sweden. And the backbone of this kind of biodiversity monitoring in Sweden is the NILS program. The NILS program is, the program manager for the NILS program is Johan Svensson. Some of you have already met him here at the meeting. And this program is based on random sampling. So we are not doing any full cover mapping or so on. It's based on random sampling. I will show some other slides later on here. And we are focusing on all kind of landscapes and and different kind of habitat types. So we are doing the inventory in forest, in agricultural land, in alpine environments, wetlands, shores, urban areas. And the main purpose is, of course, to support the national decision makers. The unique thing with this design, I think, is that it's combining several inventories into the same package. So the main sampling unit in the program is a 5 by 5 square kilometer plot. Within that plot, within those 631 sampling units, we are doing a plot-based survey, quite similar to the Tanzanian NFI. We are also doing an aerial photo interpretation of the inner part of the square, and we are doing a line intersect survey. So the sample plots are actually consisting of several circle plots. Some parameters is measured in a circle with 20 meters radius, some other with a 10-meter radius, and so on. And we are looking at land cover, habitat type, land use, different kind of impacts. We are measuring the tree layer, the shrub layer, field layer. We are looking at vascular plant species composition, moss composition, at least for a list of common species. Oops, the wrong direction here. Maybe the most innovative part of the project is the line intersect sampling. So between all sampling plots, we are doing a line intersect sampling. That means that when the surveying staff is moving between the plots, they are noting this kind of different features, for example, ditches, roads, forest edges, and things like that. And they are also trying to describe this kind of edges in different ways. So we will get data on how the forest edges, how the ditches, how the trails are changing over time. We are also doing aerial photo interpretation. And that is not, I would like to emphasize, it's not a big area. It's a 1 by 1 kilometer square in the middle of that we are interpreting presently. And in the same, and some of the parameters are the same like in the field. We are looking at land cover, tree layer, shrub layer. We are trying to make a judgment about soil moisture. Different kind of depositions, grazing, and all of those kinds are measured in polygons. Other things are measured along lines, for example, ditches, hedges, tree rows, and things. And then we also have some kind of features that are marked as points in the map. Stone mounds, for example, buildings, and things like that. We are not doing a vegetation map directly. Instead, we are doing these different kind of measurements connected to this kind of marked features in the map. And I would like to show one simple example about density distribution of alpine birch forests. This NILS program is actually the only program that are doing measurements in the whole area of this kind of alpine birch forests. So this NILS program is the official is the program that are reporting to different stakeholders about this kind of alpine birch forest. And actually last week I got a question from the Swedish EPI, not about the data itself, the reporting, but they would like to discuss and have a device about how they should define the alpine birch forest. It's a little bit complicated because alpine birch forest is defined differently depending on what kind of reporting you do. When you are doing ordinary forest reporting in Sweden, it's defined in a certain way. connected to the NFI inventory. But when you come to biodiversity monitoring, it has been, the definition has been more vague. And there are different opinions among the Swedish EPA. But by using this kind of aerial interpretation data within the NILS program, it was very easy to tell them about the consequences of using different kind of definitions. We are preferring ourselves a definition that is more closely to the FAO international definition of forests. That one of the aspects of calling it a forest or not is whether or not the crown cover is more than 10%. Of some reason in Sweden, the Swedish EPA has preferred to use a more narrow definition that the forest would have been more than 30% crown cover. And it's very easy to, from the data we have, to take out the histogram and see what the consequences will be. And you can see on the figure here that the total area covered in the alpine area of Sweden would be very different depending on the definition. But for us, this kind of definition problem is very easy to handle, because since we are doing the measurements and not the classification directly, we can report on whatever definition the stakeholders is asking for. Then we have this kind of forest, then we have the information comes from the forest inventory. It was very interesting to see that the sign of the forest inventory in Tanzania was very similar to our inventory actually, even though our inventory is much, much older. You're using a combination of permanent plots and temporary plots. You're having approximately the same number of clusters in our countries. But there was one difference though. We don't need a wildlife guard when we're out in the forest. Not so far at least. We don't know if the brown bear is continue to increase in abundance. We might have to take in another guy with a rifle with our inventory stuff too. I don't know. One important aspect with biodiversity in forest is of course looking for trying to quantify different kind of important functions. We have been talking about ecosystem functions. Another different function that is discussed a lot is, for example, the dead wood or coarse wooded debris inside the forests. One aspect that comes to my mind when working in Europe is that, and connected to the Habitats Directive, that we need to do some kind of assessment of the contribution of all the Natura 2000 network. The Natura 2000 network for you coming outside Europe is a way to organize the protected areas in Europe. And of course, when you are protecting areas, you also want to see in the long run that you get something back from this kind of restrictions that you're putting on this kind of management of the nature. And one way is, of course, to quantify different aspects inside and outside this kind of protected areas. And this is some kind of preliminary data that we have done with this kind of NFI data. We have simply estimated the volume of dead wood inside and outside protected areas for a different kind of forests. And these are classified with this kind of classification scheme developed by the European Environmental Agency, the European forest types. And as you can see, in most of the cases, the protected areas we do find much more dead wood inside the protected areas compared to outside. But this kind of table also illustrates something else. It's very difficult for you to see because the numbers are so small. But in the bottom of the bars, I have put the relative precision measured in percent. And for those of you with very sharp eyesight, you can see that some of the numbers are very high. And in some cases, we have a relative precision of 70 or 80%, and for some of the bars, we don't have an error prediction at all, because they only consist of one or two single measurements. And that simply means that when you are taking this kind of very large data set and trying to analyze smaller and smaller parts, then the information is just not sufficient. And that can be described with data from the same inventory when looking at the Annex 1 habitat types in Europe. We can see that when a habitat, for example, or some subgroup is covering a very small area, then the relative standard error will be very large. And that simply makes the measurements more or less useless. And that is actually showing the limitation of this kind of standard general multipurpose inventories. We will have very good data for things that have a high coverage, but when we are coming to measurements of features that have low coverage, then the precision just gets too low. And that was the reason why we are starting up the Life Plus project. I will try to rush a little bit here. And the main thing with this kind of Life project is we're trying a new approach. We are trying some kind of what we are calling a two-phase sampling, where we are combining remote sensing, in this case aerial interpretation, with a field survey. And it simply looks like this. We are using the same kind of squares or clusters as you are doing in the NILS program or in NFI, and we are doing aerial interpretation in the large number of sampling plots, in our case 200. These are grouped into broad categories. From these categories, we are doing a sample, depending on what category they are belonging to. And in this case, we are selecting 5 plots. The number depends on the kind of categories you are finding. And then we're sending out the field staff to those 5 points in this case. This is what it can look like, for example, in the alpine area. The arrow on the left is pointing to 1 point. This is the aerial map, and this is what it looks like in the field. And to sum up, we believe that to be able to do an assessment, a proper assessment of this kind of complicated and demanding reporting requirements, we have to use different kind of inventory programs, combining data from different kind of programs. To the right, we have this kind of multi-purpose programs doing random sampling. This is the NFI programs, and NILS is another example. They are very good for common features. They give unbiased estimates, simple computation, and they can be used for exactly what they are called multi-purpose things. The live programs is something in between. It's focused to be a complementary program to address more sparse habitat types and species. It also gives unbiased estimates, but it has a much more complicated design. And we need to a priori define the specific target habitats that they were interested in. So we are losing this kind of multi-purpose thing here. But for the really rare habitats, we probably have to do data collection in non-sites. This is also something that we are looking into in Sweden, and will develop, for example, for very rare habitats. Thanks. And thanks for the attention.